Let's welcome Luc Vũ, his solution architect of Sotatech. Sotatech has successfully provided full-cycle IT services to clients from 21 nations worldwide, with more than 350 projects, and is one of the most reputable development studio partners to local and international blockchain projects. So he will share with us on cross-chain interoperability protocols and how can we leverage protocols in developing blockchain application and products. So please, thank you.
Yeah, thank you everyone to joining this meeting. So as you know, there's two guys has talking earlier, has talked about the bridge and some kind of multi-chain, right? And they are more focused about the business side of this multi-chain. But as solution architect, then I will be also more like a technical guy. So I will present you about the depth in the bridge and how to become inter-blockchain that bring more security to the bridge. Okay. Okay, so what is the blockchain bridge? It's not only a bridge, the asset from another chain to another, but it could be some kind of transferring some information and some data from this blockchain to other blockchain. And as you can see in here, it's oh, the text is broke up somehow. It will have some kind of relayer in between and transfer the information between each blockchain. So yeah, it could be many type of bridge, like from EVM to Solana is equally the same in the layer 0. So to blockchain and from layer to layer and layer to the sidechain when we want to do something with the sidechain. Yeah. So the benefits of bridge is will, you know, when you executing the transaction on Bitcoin or on Ethereum, the transaction gas is so much costly, and we need to reduce that. Also, one block generated in Bitcoin is about 10 minutes, and in Ethereum is some kind like 5 seconds, if I remember correct. So it's very slow, and it's will not apply to enterprise chain, enterprise application. That's require a lot of that's require a lot of transaction per second. So we will have to do something with that. Also, the gas is very high. Yeah, in Ethereum, from previous, I think it's about $50 each transaction. So yeah, and also there's no communication between chain to chain because it's run on in the quarantine place, and they're not passing any information. So if you want to passing information from outside or from to another blockchain to this one, and we will have some kind of mechanism to passing the data. Yeah, and even more than that, we want every chain to join the inter-blockchain. Yeah. So firstly is I will go in depth with plastic bridge and the wormhole, aka portal. As I said, aka portal is I will talk about this one here. Okay, so how plastic work? it will transfer the access from multi-chain. It's transfer from Silo to BSC to Ethereum, from BSC to Stellar to Silo and to Ethereum. And one of these chain does not use smart contract. So we will talk about it. So it is in high-level architecture of this one. It will contain the blockchain, the synchronized roof to synchronize the transaction and the events emitted from the blockchains. And it will have the data streaming platform for the plastic hub to relay this data from operator and the validator to the destination chain. Yeah. The more detail, the more detail could be in this diagram behind. So, firstly that the front end guy, the wallet want to wrap up the token and then send to another chain, and they will have to go to the front end and doing the transaction, and the backend will record the data and then getting some fee and some calculation for this one to work. Also, after getting some confirmation and some estimated fee, it will be executed on the blockchain, and then it will emit the data. Also, emit the event log for the crawler to crawl, and after crawling the data will be transmitted to some kind of data streaming platform like Kafka, and then it will be validating the data, and after enough threshold for validation, then it will generate enough signature to push on other chain and execute successfully. And that's how it's working. And also this is how the refund work. Firstly, it will check if it's been executed on the destination chain before, and then doing some kind of calculation and asking for the signature on the validator, and then gathering enough to transferring this. Okay, so to be more specific, how we could make this bridge is some key points to understand in this. Firstly, we will able to have to split it to many kind of roles, like governance roles, admin, and the validator or the operator. Yeah, the admin is for configuration. The operator is for executing the unlock transaction or refund transaction, and the validator is in charge of signing the signature to make it more secure and avoid single failure of server. Yeah, you know, when we only run on operator to sending this unlock, right, is without validators, it might be corrupt or might be hacked, and they will use operator to unlock everything to their account, and we will have no way to prevent it if there's no multi-sig procedure in between. We will have some kind of right? Yeah, and of course the time lock, because when we want to change the state of this smart contract, like pause the smart contract, doing some kind of batching process, then it will have some need a certain amount of time to acknowledge the other person or other operation to work with, and the lock unlock mechanism is applied on this bridge. This plastic hub bridge is developed by Sotatech from bottom up, and I in charge of this in its very beginning, also to design the architecture and to coding the smart contract, also the backend. Yeah. So the second is the wormhole. The wormhole, aka portal, as I said, is why the wormhole and aka portal is been hacked before. And I will talk about the hacking process after the presenting later. And yeah. So the wormhole acts like this one. Yeah, it has many guardians from 1 to n. Yeah, each guardian could be the bootstrap and could contain the list of another guardians to get data from, to cite the signature or to validating the data. And each guardian can be configured to be the backend, and the front end will able to connect to and execute. In this diagram, you can see that it's not the same as the every hub, because the every hub is the single server, and if anything that happen with the relay hub or refund service, and considering it's down for goods, yeah. But in this one, everyone can be the back-end guys or the operator. So yeah, if one guardian is down, then it's not matter. And if it's able to reach the threshold, then it's not matter. Yeah. So and then here is the flow of the portal. Yeah. So firstly, is front end guys, the wallet. The user will generate some kind of payload, and then asking for payload return with some encryption. Yeah. So after that, it will be executed on the blockchain, and then all the nodes will be able to cross the data, synchronize the data from the blockchain, and then the customer will asking for the site signature for completing this envelope to send to other chain, to be able to unlock it in other chain. And it had many. It had two important functions: is transfer the token, and to claim the token when the transferring is failed, or the destination chain does not have enough access to be unlocked to the other to the person. Yeah. And also it will be have some advantage than the plastic bridge. We will talk in the next slide. Yeah. So in the plastic model, you can see that it has a lot of disadvantage, because it will use single hub for executing the transaction, also using the operator to execute the transaction, not letting the user to use the transaction. So it's just the system, and the portal is a trustless system. Yeah. Okay. So it's the plastic hub is lack of the governance authority in the community, and it's run by one company. So if the company want to hack all of his system or want to withdraw all of this asset on this smart contract, then of course they are able to do so. And the community governance is not able to do anything with this smart contract, and it has no deals. Yeah, it had no voting for state chain or the proposal or something like that. And if there is no voting or just only one person can execute it, then it don't have secure. And okay, so the operator gas is because in the previous diagram, right? The operator will execute the transaction, not the customer execute the transaction like wormhole. Therefore, it will be cost some gas, and which will be it will have the operation to maintain this operator gas and to maintain the native balance in this architecture, and also it will cost a lot of maintenance efforts to be work with system, but yeah, but somehow I still develop that, yeah, somehow because it's have the it has a chain that don't use smart contract. So in order to use this bridge to transfer the token to this chain, we will have to use the custodian model. And to apply to the whole system, then we have to use the operator to execute this transaction, not letting the customer to do it. Yeah. Yeah. Okay, so it is very centralized. We will have to make it to become more decentralized. Yeah. So to become more decentralized, we minimize the risk of single point failure, because when the backend is down, it's a single point. It's only point that that could be and it's failed, then no use to the system, right? And you can see in this diagram, in this wormhole diagram, it could avoid the single point failure, because it had many guardian, and each guardian can act as the stroke of this backend. Yeah. So of course this is the disadvantage of the plastic hub. Yeah. And the second thing is to avoid the operator gas. When the transaction is bigger and bigger in number, we are not able to frequently tracking the gas fee and tracking the balance of the operator, right? And just simple that we will let the customer execute the transaction for us, then it will be not costing any gas, and it's more efficient for the server to not have too many requests to this blockchain. Yeah, and also if we don't use gas on the operator, then we don't have to maintain every time to checking the system and become decentralized like many guardian and many other communities take the control of this operation. Then it will not need too much of maintenance, for example like my company, but let the other also in charge of this maintenance. Yeah. Okay, so the key point to make it decentralized is using proposal. Yeah, using deals to make proposal to let another parties to involve when validating, or when some stage change in the smart contract, like pausing the smart contract or emergency withdrawal when the smart contract has some problem. Yeah. And the community governance, because don't let single company to keep all the thing, right? Yeah, if they keep all the things to themselves, and everything could happen. Yeah, maybe one of the developer want to hack a system. Yeah, if they know enough of the knowledge, then they could hack the system, and all the things will be lost. Okay, so with the multi-signatures, we added to the system more security, because when we're using only single one to execute this transaction, then anyone that's been leaked the key could be a problem. Another thing is peer-to-peer communication, because to connect to node and to the guardian, we will have to be some way to communicate with, and it will have to establish some kind of peer-to-peer, because with it will no need the back end to the server to relay this communication message. So we have to establish some kind of peer-to-peer communication and securing it. Yeah. Also the Merkle tree, because nowadays there's many transactions being executed on the blockchain, right? If we execute it every time the connection is the transfer happen, then which will cost more gas, and to maintain the integrity of the system, we will have to push some proof to the other chain, and on this chain to prove that it had been happened on this previous blockchain before, and when the person claimed the assets on the destination chain, or on this or refund on this chain, will be able to validate that whether it is completed before, or it has the knowledge before. Yeah. Yeah. So that is about this how to become decentralized. Of course, the bridge is far more from perfect. It has many flaws. Yeah, like the wormhole architecture is decentralized, right? But it's been hacked. It's been hacked by the problem with the smart contract when wrapping the token and when pairing the token from chain to chain. So we have to make something to secure that. Yeah. Yeah. So it's when we as I said before, I present you the plastic bridge and the wormhole, right? It's two variations of the bridge. And why does this has two variation? Because it does not follow any standard. Yeah, it's because it does not follow any standard, and therefore it has some flaw to exploit. When we have some kind of standard and protocol, the protocol is proven by many people and many developers before, so we will make it more secure by auditing existing code and reusing the code that been applied to many programs without any problem. So it will have some standard. To have some standard, right? We will have some kind of protocol, and we will call this one is inter-blockchain protocol. In the core system, it still be the bridge, but it's more advanced, more security than bridge. Yeah. So basically, it will have some kind of layer that's connect into the blockchain and transferring the data from other. It's still the same with the bridge, but we're not using the smart contract to bridge the token, rather than have some standard. Also, some kind of implementation is will have we modify like existing blockchain consensus to be able to have some new type of transaction like inter-blockchain transaction to do with that, and we could avoid the smart contract using a smart contract. Yeah. So in this first picture is we will have some kind of relayer, but this relayer is inside this blockchain, and it is a part of the consensus, and another type of transaction like called inter-blockchain transaction. That's we will be able to get the data from other blockchain, and then using consensus to submit it into the destination chain. Is we passing the information between each other like any system, any backend system. Also, there's some implementation like Code Mode Hub in here. Is we were using the IBC protocol, and it will be more advanced in the next. Basically, what I explained is this picture above. Is we will have the relay layer to that's coding inside the blockchain and follows the standard, and the other type is the same as Polkadot. Yeah, we will have to create some kind of relay chain, and everyone using the same standard to be more secure and to be decentralized. Yeah. Yeah, so if we are using inter-blockchain protocol, then we could eliminate the custodian bridge, like every hub, using operator to execute transaction, and using custodian account to store asset on Stellar, because Stellar don't have the smart contract, and it's the same as it's nearly the same as Bitcoin. So we will have the custodian account to store the assets. Yeah. So it will have to act as the layered blockchain, and the relayer will act as the relayer and storing and proof. This transaction proof, this information being pushed on the blockchain is valid, and decentralized and transparent, and no more hiding anything from the communities, right? Because when hiding the information from communities, no one can audit the system, or no one can exploit and improve the system. So it has to be transparent and open source. And it will have its own consensus like another, like blockchain, like proof of authority, when it's reached enough threshold or proof of stake, when anyone has a part and have a percentage of the threshold in it. Also, of course, it will have the governance models, and it will be trusted by the communities and so on. Since it be a protocol, so it will have a set of standards to other person to integrate with this type of inter-blockchain have to follow. Yeah. Just like some protocol in the network, TCP or UDP, right? Okay, so is this perfect? Of course, it's still far from perfect. Nothing is perfect actually, yeah. But it's far more secure than other bridge, far more secure, because it has its own consensus, it's decentralized, and each node can act as the operation act in the operation. So and because it have a set of standards, all the person and open source working with that, so it's being proven and improved over time, right? So in the next session, I will talk about the example of this inter-blockchain protocol use case. We will have some example like Cosmos IBC and Polkadot HCMP. So IBC is standards for communication among heterogeneous smart contract capable chain. It means those chains that have the smart contract implementation within it. And the communication layer is a layer that's been integrated into the blockchain. Yeah, it's been okay. So fast forward for this problem is we have some diagram to show the flow of this one. The first thing is we send the package to the core, and the layer will query the package and send to the layer to the blockchain B, and it will generate some kind of acknowledgement and then execute it on the B, and the relayers will send the result to the acknowledgement package to the blockchain A. Okay, and okay, this one is Polkadot HCMP. It's have the different implementation is we will have some kind of relay chain into that. In the between from the parachain, it's not like Cosmos IBC, because the IBC will have to be the same blockchain that implement the protocol, but this one does not. Yeah. This one is support the layer is called correlator, and the message is crossing between chain is called ICM, and it has 4 main components. First main component is relay chain in the middle, and the parachain is the one that's hooked into the relay chain, and the parathread is also at the parachain, but sometimes it's execute, sometimes it's off due to reservation of this Polkadot. And then the bridge, because the parachain will connect to some kind of sometimes it has its own blockchain, sometimes it acts as a bridge and transfer the token to this parachain. It takes advantage of this relayer, because the relayer is in charge of security in this one. It will be validated for many chains that's hooked into. Okay, so the interaction between the parachain is it has a message, and it puts with flow to this ICM protocol, and then there will be some complicated process like voting and validating this in the relayer, but because this is the end of my time, so I will not be able to focus on the technical detail of it. Yeah. So to be compared with IBC and Polkadot, right? It's the IBC will be the IBC relayer, and it's only chain that's implemented with the IBC protocol should be able to communicate with each other, but the other chain is not. So yeah, it's the limit of this one. Also, this Polkadot is on the relay chain, so the relay chain is limited in slot. Yeah, Because the parachain is they said about 100 slots for parachain, and they will have to some kind of staking and they open some kind of auction to the other people to opting the slot in this one, and the incentive is a transaction fee in Polkadot. Yeah. The ending thought is inter-blockchain is very, very promising because nowadays everyone every system want to take advantage of the blockchain, but some blockchain is slow, some does not have smart contract, or some is complicated. So complicated, and the inter-blockchain is the solution for it. It will transfer the access to the other, and we take advantage of this ecosystem to be able to have high TPS, high transaction per second, DeFi system or some kind of this. Yeah, but it will have to follow standard to be able to more secure. And also, Sotatech is implementing the standards of inter-blockchain protocol. So if anyone is curious about it, you can ask me about this future incoming of this project in Sotatech. Of course, it will be some kind of between the Cosmos IBC and the Polkadot XCMP. So it's more advanced, and in the future, right now it's in the development phase. So I don't just want to leak the information of it. Yeah, this is my ending here. So I hope you guys understand what I said, and if you guys don't understand any of this, then you could email me to luc.vũ@sotatech.com or send to Sotatech email, and I will try to reply all of this, and we will focus more on the technical problem to solving the issue. Yeah, thank you for everyone to listening this one.
Xin được cảm ơn anh Lực Vũ. Thank you very much for your sharing.